we have question number 10. The balloon is in the shape of a sphere. Now we understand that a sphere, okay, let me just take away this one. Okay, a sphere is basically, it has a volume and an area. So because we're talking about volume here, so we're going to say the volume of the sphere is given as 4/3 pi r cubed. Immediately when we get a question on differential equation like this, we can differentiate volume and say dV by dr, because we're going to need it, is going to be equal to 3 times 4/3 pi r to the power 3 minus 1. So that becomes then 4 pi r square. Now we understand that this is dV over dr. At some point, of course, we're going to need it. Right. The first thing is air is pumped into the balloon. So we have an inflow of air into the balloon at a constant rate of 40 pi, starting when time t is equal to 0, r is equal to 0. At the same time, air begins to flow out. Now we have an outflow. So when we have an inflow and outflow, we will have what we call a net flow as well. A net flow is going to be the inflow minus the outflow. So basically what I'm saying is the inflow here is 40 pi. So I got then 40 pi minus the outflow is 0.8 pi r. Now all of that is referring to the net flow. That is the change in volume, because the change in volume, meaning that volume of air is getting in and out. So we have dV with respect to time, So with respect to time means volume is changing over time, dV over dt, right? So we have dV over dt, and so this is what we have basically. Now this is the net flow. But we need to show that R and T satisfy this differential equation here, 50 minus R over 50 over 5R squared. Now what is dr over dt? First of all, I'm going to use the formula dV over dt, dV over dr, which we found here. This is dV over dr. It's going to also be equal to dV over dt times dt over dr. It's like the chain rule. So here, very important. So this is dV over dr is called dV over dt times dt over dr. Now dV over dr, we just found, we calculated, we differentiated the volume, and it was actually here, 4 pi r squared. So this is going to be equal to 4 pi r to the square. And all of that is equal to dV over dt. And the dV over dt we just found this one here. So that's 40 minus 0.8 pi r. And all of that multiplied by dt over dr. So we're almost there. We have dt over dr here. There was the one dr over dt. So we're going to have to swap this around. The dr can go on the other side, and the dt can go, because this is multiplied here. So the dt goes down on the other side. And over here, I've got 40 minus 0.8 pi r, all of that divided by 4 pi r squared. Now, if I were to simplify this further, what is, I can put the 0.8 outside if I want. Okay, so 0.8, and was that 40 pi? Yes, it was 40 pi, because look here, 40 pi. So we're going to say 40 pi. So the pi is common, the pi can go outside. And then inside I've got, because we know that 50 multiplied by 0.8 is going to give you 40. So then minus the r, because 0.8 pi is outside. And all of that being divided by 4 pi r. Now the pi and the pi can cross out. And if I were to take 0.8 over 40, over 4, it's going to be, move the one decimal place, alright, so 8 over 40, which is 1 over 5. So what we have is then 1 over 5. So basically what we're saying is this is now 50 minus r divided by 1 over 5. So this is pi, just bear with me a moment. So d over dt, 4 pi r square here, there was a square here, 4 pi r square. Shouldn't let that go. So that's 5 r to the square, because we did say that all of that here is going to be divided by 5. So now this comes to 50 minus r divided by 5r to the square, and we can see now that this has been shown. Here we are. Okay, so now we're going to move on to the second part of the question. We need to find the quotient and the remainder when 5r squared is divided by 50 minus r. So how are we going to do this? Let us see. It's just basic long division. Alright, so let us see now. So I'm going to perform a long division over here. And we have to take 5r squared and divide this by 50 minus r. Okay. So let me just write this down again. 50 minus r. Now, what is 5r squared divided by minus r? It's not going to be minus 5r. So minus 5r times minus 5r times r is 5r to the square, and minus 5r times 50 is minus 250r. And so now if we subtract this, these two is going to cancel out, minus minus becomes plus. I end up with 250r. And the 250r divided by minus r is minus 250. So minus 250 times 50, or minus 250 times minus r is plus 250r, and then minus 250 times 50 is minus 12,500. So now we subtract this, and these two cancels out, minus minus turns out to be plus, so we got this as 12,500. Now this is our remainder, that's the quotient. So again we're going to have to write it down. So the quotient and remainder. So we have quotient as minus 5r minus 250 on top there, and then we have the remainder. Okay, remainder is 12,500. So here we are. These are the two answers for part B of the question, carries 3 marks. Now, the other part of the question is we need to solve the differential equation in part A, and we have to obtain an expression for t in terms of r. Now this is a very interesting question. To solve this differential equation, what was the differential equation in part A? So we go there and see. The differential equation was dr over dt is equal to 50 minus r over 5r squared. Okay, so dr over dt is equal to 50 minus r over r to the square. Now, if we have to solve a differential equation, is it r squared? Hang on a second, let me just check again. Not 5r squared, 5r squared. Alright, okay. Gotta be careful. Okay, now we have to solve this differential equation. So I'm going to separate the variables. That is, we're going to bring all the r's on one side and all the t's on one side. So 5r squared can go up on the other side, becomes 5r to the square. And this 50, and remember, all of that is being multiplied by 1, alright? So, and then the 50 minus r can go on the other side, but 50 minus r. And we have the dr here, so the dr is here. This is our left-hand side. On the right-hand side, I got this 1 here, and the dt can be set up there and gets multiplied. Once I have this, I'm just going to integrate both sides, okay? So now 5r squared divided by 50 minus r, we did that in the second part of the question. We had the quotient and the remainder. Now what do we have? We have minus 5r minus 250, all of that divided by 12,500. All of that add on to. So basically this is we take the quotient, we add it to the remainder over the divisor. This is our divisor. So quotient add on to the remainder over dv. Let me just write this down. Okay, we take the quotient, add on to the remainder over the divisor. So this is the left hand side. The quotient was minus 5 or minus 250. So we're going to add on to the remainder. Remainder was 12,500, and then divide by our divisor. The divisor was 5 or was it 5 or 50 minus r. 50 minus r. So here we are. So I'm going to take 50 minus r. Right, so now this is our left hand side, and we can then integrate that with respect to r, dr. So, and all of that's going to, now if we integrate 1 dt, so we're basically integrating 1 dt. So let's try and integrate each one of these. So if we do this, 5 minus 5r is going to become minus 5r to the square. If you integrate, you add 1 to the power, and then you divide by the power. I'm going to leave it as a fraction, and then minus 250r. Some students might leave it as a decimal. It doesn't really matter. And then here I've got 1 over 50, 12,500 over 50 minus r. So can I say 12,500? If we integrate 1 over x, we get ln x. So 1 over 50 minus r is ln 50 minus r. And because we need to differentiate the denominator, if we differentiate this, we're going to get minus 1. Now, if we divide this by minus 1, and then on the right-hand side, if I integrate 1 in terms of t, I'm going to get t. Then add a constant. The constant is k, right? So now I have minus 5 over 2r to the square minus 250r. Okay, minus, with the plus minus becomes minus 12,500 ln 50 minus r. And now it's the time for me to use, some student might put this as c as well. I'm going to use the initial condition. So I'm going to substitute the initial values into the equations. Initial values, okay, to find our constant k. So what was the initial values? Let's take a look at the question now. The question at the beginning, we had, look at this here, balloon is in the shape of a sphere, okay, and air is pumped into the balloon at a constant rate starting when the time t is equal to 0 when r is equal to 0. Okay, so t is equal to 0 when r is equal to 0. I'm going to substitute these into the equation. Okay, so over here, now t is equal to 0 when r is equal to 0. So I'm going to put 0 here, so minus 5 over 2 times 0 to the square, minus 250 times 0. Of course, the balloon is flat at the beginning, so the radius is 0. So minus 12,500 ln 50 minus 0, which is then 50, then is equal to t. T was, we thought t is 0. At the start, the time is 0. So it makes sense to me. So this is 0, and then plus our k. So basically now what we have is k is equal to minus 12,500 ln 50. So if I rewrite my differential equation, I'm going to get minus 5 over 2r to the square, okay, minus 250r, alright, minus 12,500 ln 50 minus r, and of course plus t. Is equal to t. Alright, is equal to t. And then plus k, and k was found to be minus 12,500 ln 50. Now, we want to find t in terms of r, so everything here that is connected with t can be sent over to the other side. So I can say that t is equal to minus 5 over 2r to the square minus 250r minus 12,500 ln 50, okay, minus r, and then plus, because this can be set on this side, so it becomes plus 12,500 ln 50. So this is my answer to the question. Now, some students might use the laws of logarithms by putting this in a different form. They might say 12,550 divided by 12,500. Okay, so I don't want to, I just want to leave it like that. There's no hard and fast rule. The last part, I did it on the screen here, and we are being told that find the value of t when the radius of the balloon is 12. Now the radius is 12. I'm taking the equation again. So this is the equation, t is equal to minus 5 2r square minus 250r and so on. We can take that equation and replace t as 12, because they said, is that t is 12? Yeah. No, sorry, the radius is 12. So everywhere where we got r, I'm going to replace the r by 12. And if I do so, as you can see, the calculation has been done here just to save time. 5 by 2, 12 square minus 250 times 12 minus 250, 12,500, ln 38, why 30? Because we did have 50 minus now 12. So that's going to turn into ln 38. And here we are, ln 38. And if you were to wrap this up, you should be able to get t as 70.5. I guess this question answers pretty much a lot in terms of differential equations as a word problem there. Okay.